Yeah. Good evening, children. Welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Let us go to the today's class. Right. So today we are going to discuss about the rational numbers concept, children. So in previous class we have discussed already about that fractions, no? So in that we left some problems. Let us finish that problems. Then we go to the rational numbers topic. Okay? Yeah. So synopsis 10. Yeah, exercise 1, 11 problems completed. So let us go to the 12th one. Okay. So let us finish that synopsis 10 exercise 1 problems. Okay. Yeah. So question number 12 while you are observing here. So these are all based on the fractions topic, right? Yeah. So we have discussed about the different type of fractions like proper, improper, vulgar fraction, decimal fraction, mixed fraction, improper fraction, equivalent fractions, like fractions, unlike fractions, unit fractions, like some different type of fractions we have discussed about it, and based on that we have solved some problems also. So let us check 12th problem now. The fraction is equivalent to, so 2 into m plus 1 by 19. For m value is 9. For m value is 9. That means we need to find out the value of this fraction. But here one of the letter m is given. The m value is also given, that is 9. We need to identify this value when we substitute m value is 9. That means whenever you see m, we need to write 9. So let us take this given one. 2 into m. 2 into m. M value is how much? 9. Okay, na? So 2 into 9 plus 1 by 19. Yeah, 2 nines are how much? 2 nines are 18. 18 plus 1, 19. So numerator is 19. Denominator also 19. Both are same numbers. So 19 table in 19, one time cancelled. So therefore the answer is 1. Okay, na? So the given condition is 2 into m plus 1 divided by 19 for m value is 9. So whenever m value is 9, we need to find the value. If m value is 10 also can ask, then in the place of in the place of m, we need to substitute 10. Okay, na? If m is 10 is given. Right. So this is the value of 12th question. Now let us find 13th one. So it is given that 10 pies as fraction in rupees. 10 pies is fraction in rupees. Right. So actually we should know that 1 rupee equals to how many pies? 1 rupee equals to, very good, 100 pies. Okay, 1 rupee equals to 100 pies. Now we need to express 10 rupees in the form of fraction. Sorry, 10 pies in the form of fraction. So let us consider that 10 pies, how much fraction in 1 rupee? 10 pies is how much fraction in 1 rupee? That means 10 pies by 1 rupee. So just now we discussed that 1 rupee is nothing but 100 pies. Here 10 pies, here 1 rupee, different measurements. So we need to convert them into same. So 10 pies as it is. By 1 rupee we can write as pies. 1 rupee equals to 100 pies. Okay, na? So now both are in the same measurement pies. We can neglect the measurement here. Now what is the remaining here? 10 by 100. Both they will cancel in, yes, 10 table. 10 ones are 10, 10 tens are 100. So 1 by 10 is a required fraction when you convert 10 pies to 1 rupee as a fractional form. 10 pies to 1 rupee. 10 pies to 1 rupee in fractional form will be 1 by 10. Okay, na? Right. Now let us think about that question number 14. You got it right? Any other doubts? Okay. Now I am going to next question. Question number 14. Yeah. So if 3 2 by 3. 3 2 by 3 means which type of fraction? It is a mixed fraction. See, whole number with proper fraction is called mixed fraction. So it is a mixed fraction. This mixed fraction we can convert it into improper fraction also. So while you are observing, the question is 3 2 by 3 is converted into improper fraction and its numerator is 8 plus k. So after conversion of that mixed fraction to improper, we have to take that numerator as 8 plus k. Then we need to find the k value. Okay. Let us try to convert them into improper fraction. How to convert? Yes, 3 into 3. First we should do multiplication with this whole number with the denominator. So 3 3s are 9. 9 plus 2, 11. So 3 2 by 3 is nothing but 11 by 3. In 11 by 3, what is the numerator? 11. So question is given, the numerator is equals to 8 plus k, it seems. What is numerator here? 11. So 8 plus k value is 11. So k is equals to, now plus 8 we have to transpose that set, or you can count like this. How much you should add to 11, how much you should add to 8 to get 11? 8 after 9, 10, 11, only 3 numbers, right? Yes, so 8 plus 3 becomes 9, k value you can easily find it is a 3. Or else plus 8 transpose this side becomes minus 8, 11 minus 8 is 3. 11 minus 8 is 3, that means k value is 3. Okay now? So first time converting the mixed fraction into improper fraction. Then the numerator I made equals to 8 plus k. From that I can find a k value. Okay, check. Next, question number 15. Okay? Yeah. So this one, again same question, 7 8 by 9 is converted into 7 8 by 9 is converted into improper fraction. Again the numerator is 70 plus x. Same process. Let us find the improper fraction of this. First multiplication, 9 7s are 63. 63 plus 8, 71. 63 plus 8 is 71. 71 by 9. So among them, what is the numerator? Very good. Numerator is 71. Therefore, the numerator is, we should make it as equals to 70 plus x. Yeah, 70 plus x equal to 71. Now just tell me the answer. For 70, how much you should add to become 71? 1. So that's it. X value 1. Or transpose 70 that side, minus 70. 71 minus 70 is 1. So x value is 1. We can do like this also. Okay na? Please note it. Okay. Now, next problem. I think you are able to catch. So just addition and subtraction only, no? So that's why I am going little bit faster. Okay. Yeah. So problem number 16. That is, if 5 by 9 minus 1 by 9, 5 by 9 minus 1 by 9 is given, that is x. Okay, now let us simplify this. Still problem is there. Then we need to find that x plus 5 by 9. Again we need to find that x plus 5 by 9. Okay, now? Yeah. Right. So let us simplify this. First fraction is 5 by 9. Second fraction is 1 by 9. So both are like fractions or unlike fractions? Like fractions. Okay, na? because both are having the same denominator. We discussed that fractions having same denominator like fractions, fractions having different denominators are unlike fractions, right? Yeah. So for adding or subtracting fractional numbers, first of all we should check they are in like fractions or not. Okay, otherwise we need to convert them into like fractions. Okay, if the questions are given the like fractions directly, we can add or subtract the numerators. If it is not given the like fractions, we have to convert them into like fractions by doing LCM of denominators. Okay, yeah, so both are having the same denominator 9, same denominator 9. So what is numerator here? 5. 5 minus 1. 5 minus 1 value how much? Very good, 4. 5 minus 1 value is 4. So the answer is 4 by 9. X value we got. X value is 4 by 9. But problem is not yet n. We need to find x plus 5 by 9 value. So now itself we found x value is 4 by 9. So in the place of x, I can write 4 by 9. Here plus symbol, plus as it is. 5 by 9. Yeah, write 5 by 9 as it is here. Again, both are like fractions. We can directly add the numerators because middle plus symbol is there. That's why add numerators. 4 plus 5. 4 plus 5 value. 4 plus 5 is 9. Denominator also 9. 9 by 9 means 9 table in 9, 1 time cancel. Answer 1. Yeah, note that. So that's it for synopsis 10. Next we need to go to the synopsis 11, nothing but rational numbers. Today we are going to discuss about rational numbers topic. Okay na? Right. So I am arranging these all. Synopsis 11. Now about rational numbers, okay? So until then you learn different type of number systems like natural numbers, whole numbers, integers. Now rational numbers. Rational numbers are nothing but the numbers which can be written in the form of p by q. The numbers which can be written in the form of p by q are called rational numbers. Okay? So numbers can be written in the form of p by q are called rational numbers. Okay na? Here p comma q are integers. P and q are integers and q does not equals to 0. The condition is q does not equals to 0 because if the denominator value becomes 0, the value is does not exist. That means we cannot define that value. Okay, that's where we are taking the condition q does not equals to 0. P and q are integers. That means p can be any positive integer, negative integer and 0 also. Q also can be any positive number, any negative number, but it cannot be 0. Okay na? So such type of numbers are called rational numbers. Such type of numbers are called rational numbers. Okay na? So that means example while you are taking that 5 by 6 minus 7 by 3. While you are checking the fractions, always positive numbers. There is no negative number in the fractions. Okay na? So this is negative, see, minus 7 by 3. Negative part. That means it is a rational number. Minus 2 by minus 5. 1 by minus 3. 6 by 7, 12 by 5. These are all rational numbers. Example for rational numbers. Okay, now? So these are all in the form of P by Q. But while you are checking that number 5, if you take only number 5, is it a rational number or not? Because it is not in the form of P by Q, right? No. 5 we can write in the form of P by Q. That means 5 by 1 we can write. Or we can write 5 as 10 by 2. 10 by 2 means 5 only. P by Q form. Or 15 by 3. 15 by 3 also 5 only. Okay, na? So the numbers which are in the form of P by Q are called rational numbers, where P and Q are integers, Q not equal to 0. Okay, na? Right. It is also having another name, that is called quotient numbers. What is that? Quotient numbers. So that's why the rational numbers are represented with the letter capital Q. Natural numbers are represented with the letter capital N. Whole numbers are represented with the letter capital W. Integers capital I or Z. Z means Jahlan. Okay, na? Rational numbers means Q, because it is having another number or the another name, quotient numbers. Okay, na? Yeah, please note it. Next, let us discuss about the positive rational numbers and negative rational numbers. Positive rationals or rational numbers and negative rational numbers. Positive rational numbers means both numerator and denominator of a rational number. Both numerator and denominator of a rational number having the same sign. Such type of rational numbers are called positive rational numbers. Okay, na? What is that? Both numerator and denominator having same sign. Okay, na? Such type of rational numbers are called positive rational numbers. Positive rational numbers means always need not be positive symbol for both numerator and denominator. Both numerator and denominator having the same sign only, we are calling that positive rational number. That means minus 5 by minus 6. Numerator is negative, denominator also negative. So this is a positive rational number. 7 by 8, both are having plus symbols. Plus 7 plus 8, it is also a rational number, positive rational number. Okay, na? Minus 12 by minus 15, it is also a positive rational number. So both numerator and denominator having same sign, positive rational number. Different sign is negative rational number. Okay, na? So what is negative rational number? Both numerator and denominator having different sign. Both numerator and denominator having different sign. Okay, na? So let us see some examples here. That is minus 5 by 6. So numerator is negative sign, minus 5 is negative integer, denominator is positive 6. So opposite sign, it is a negative integer. Sorry, negative rational number. Same way, 3 by minus 5 or 3 by minus 7. It is also a negative rational number. Numerator is positive, denominator is negative. So it is a negative rational number example. Okay, no? So rational numbers are nothing but the numbers which can be written in the form of P by Q are called rational numbers. P and Q are integers, Q does not equal to 0. Examples. Next, positive, another name of rational numbers is quotient numbers. We are representing with the letter Q. Positive rational numbers to negative rational numbers. Okay, no? Check. Next we are going to discuss about standard form of a rational number. Okay na? So before that, 0 is a rational number or not? 0 is a rational number or not? Yes, 0 is a rational number because we can write 0 as 0 by 1, 0 by 2, 0 by 3, 0 by 4. We can write in any form because 0 by anything 0 only. 0 by anything is 0 only. So 0 is a rational number. Okay na? Yeah. But any number by 0 like 1 by 0, 2 by 0, 3 by 0, it is not a rational number. Because in the definition only I given that the q value does not equal to 0. That means the denominator does not equal to 0. Anything by 0 is not defined. 0 by anything is 0, but anything by 0 is not defined. Okay na? Yeah. Now, standard form of a rational number or simplest form of a rational number. Standard form. For example, if you take any rational number, whatever you want, if you take any rational number, the rational number always in simplest form. That means there is no common factor except 1 between numerator and denominator. Then we can consider that the rational number is in standard form or simplest form. And also, the denominator never becomes negative. The denominator of a fraction should not be negative. Okay na? So what is that? Standard form is the numerator and denominator must be in simplest form. Let us take one example. Example 1 I am taking here. Standard form is I am taking here 56 by 90 or 56 by 64. Okay na? So this is a rational number. It is having numerator and denominator p by q form. It is a rational number p by q form. Okay na? But it is not in simplest form and standard form because while you are observing 56 and 64, both are having common factors. Both will come in 6 table. Both will come in 4 table. Both will come in 2 table. So not 6 table. Both will come in 2 table, 4 table, 8 table also. Now I am going to cancel 8 table from both of the numerator and denominator. 8 table in 56 7 times. 8 table in 64 8 times. So 7 by 8. I cancel both of them in 8 table. Now 7 and 8. Any cancellation between 7 and 8? No, because no common factor except 1. So 7 by 8 is simplest form. 7 by 8 is simplest form of 56 by 64. Okay na? That too, we need to check the denominator. Denominator is positive number or negative number? 8 is a positive integer. Yes, it is in standard form. Let us take one more example here. 12 by minus 15. Is it in standard form? No, because 12 and 15 having a common factor 3. Now I am cancelling both of them in 3 table. 3 4s are 12, 3 5s are 15. That means after cancellation 4 by 5 denominator having negative. It is not in simplest form or standard form because there is no common factor, okay, but the denominator should not have the negative symbol. So what we do? The same negative symbol we are moving to numerator. So minus 4 by 5. This is in standard form. It is not in standard form. Okay na? The same negative we are just moving to numerator. Now it is in standard form. You are leaving the negative symbol like this for the denominator. It is not in the standard form. Okay na? Check. Now one more example let us take. Minus 48 by minus 64. Minus 48 by minus 64. Both are negative symbols. So positive rational number. Numerator is negative sign, denominator also negative sign. So both are having the same sign, positive rational number. Opposite sign, negative rational number. Okay, na? Yeah. Now both will cancel in 8 table. 8 6s are 48. 8 8s are 64. Again 6 8 both are coming in 2 table. 2 3s are 2 4s are. Now there is no cancellation 3 by 4. That means minus 3 by minus 4. It is not in simplest form. So both are same symbol. Now we can cancel. Minus minus cancel. Now 3 by 4. Denominator is positive. Yes, it is a simplest form. So the simplest form of minus 48 by 64. Minus 64 is 3 by 4. Okay, check. Yeah. So let us go to the next concept. Now comparison between the rational number. So usually in numbers we are comparing for knowing which is greater number and which is smaller number. For about that remaining subject it doesn't matter. So while you are checking that comparison between any two quantities or any two shapes or whatever, we are checking that in mathematics about which is smaller and which is larger. Okay, na? Now here comparison. Let us check the comparison. Okay. For example, if you identify any two rational numbers, first rational number is a by b and the second rational number is c by d. Like two rational numbers are given like this. Two rational numbers are given like this. Both are having different denominators. Here b and here d. Okay, na? For this, to identify which is smaller and which is greater, we just do cross multiplication. That means a into d, first one here, numerator onwards we should take. A into d and second one is b into c. Just apply the cross multiplication. In this cross multiplication, the first product is greater than the second one. We can say that the first fraction is greater than the second fraction. Now, if the product c and d, b and c, first one a into d is less than b into c, we can say that first fraction is less than the second fraction. Nothing but first rational number is less than the second rational number. In case a into d equals to b into c, both are equal, then yes, first rational number equals to second rational number. We can say that both are equivalent rational numbers. Okay. So if two fractions, if you are observing like this, apply the cross multiplication, the product of first numerator and second denominator, a into d is greater than b into c, then we can say that first fraction is greater than second fraction. If you get that less than, first fraction is less than the second fraction. If you get equals to, first fraction equals to second fraction. Okay, na? Yeah, please check. Let us take one example based on this. For example, I am taking that 5 by 6 first rational number and 7 by 8 second rational number. Let me try to apply the cross multiplication to compare these two, because both are different denominators. Same denominators means we can apply clearly, right? Same denominator means if the numerator is bigger, the fraction is bigger one. If the numerator is smaller, that is smaller. Okay. Now cross multiplication, 5 into 8. Now here 6 into 7. 5 8s are how much? 5 8s are 40. This one 42. Which is more? Second one is bigger. That means 5 by 6 is less than 7 by 8. Okay. 5 by 6 is less than 7 by 8. This is the comparison between two rational numbers. Please check, children. So what we discussed, what are rational numbers we discussed, and what are positive rational numbers, what are negative rational numbers, and standard form of a rational number. Okay, na? Then we discussed about that comparison between the rational numbers, any two rational numbers. Okay. Now here one more point we have to discuss. That means rational numbers on number line we need to discuss. At the same time, if you take any two rational numbers, between how many rational numbers are will come. That point also we need to discuss. Okay. Let us discuss about the number line. For example, how to represent 5 by 7 on the number line. 5 by 7 on the number line. So simply we are taking a number line like this. 5 by 7 is positive rational number or negative rational number? Yes, it is a positive rational number because numerator denominator having same sign. So positive rational number. All positive numbers are right side of 0. All positive rational numbers are right side of the 0. All negative rational numbers are left side of 0. All negative rational numbers are left side of 0. Now right side here, what is the denominator? 7. So 0 after first one is 1 by 7. 0 after 1 no, but we need to represent 5 by 7. So first rational number is 1 by 7 with the same equal distance. Second rational number is 2 by 7. Next 3 by 7. Next one 4 by 7. 5 by 7. 6 by 7. 7 by 7. 7 by 7 means 1 itself. But we need to represent 5 by 7. So among them 5 by 7 is this. Like this we need to represent the rational numbers on number line. Now how to represent the negative rational number? Minus 3 by 4. How to represent minus 3 by 4 on the number line? So we know that minus 3 by 4 is negative rational number. Negative rational numbers are always left side of 0. So I am taking 0 here. They are being left side of 0. So what is the first here? Denominator 4. So negatives are left side of 0 means first one minus 1 by 4. Second one minus 2 by 4. Third one minus 3 by 4. Fourth one minus 4 by 4. Both are getting same number, same numerator 4 by 4. Until then you should write. So among them what we need? Minus 3 by 4. So this is the representation of minus 3 by 4 on number line. Okay? Yeah, once note it. Okay. Now let us go to the rational numbers topic. Between numbers. Okay, between numbers later we can discuss. Let us see some exercise problems based on this. Okay. Yeah, practice sheet 1. Now the practice sheet 1. First question, which of the following is a rational number is positive? Which of the following is a rational number is positive? That means we need to identify the positive rational number. What is positive rational number according to the definition? Both numerator and denominator having same sign. Now check the options which are having the same sign. Yes, second option, that is minus 5 by minus 8. Both are having the same sign. So it is a positive rational number. Okay, na? We need to find positive rational from the given options. So this is our required answer. Okay. So let us go to the second question. The second question is, which of the following rational number is positive? Again positive rational number only. That means positive rational number means all must be having the same sign. That means numerator and denominator having same sign. Check that one. First one is minus 6 by 17. So numerator is minus 6, so denominator is plus 17. So opposite sign, negative rational number. Second one 5 by 8. Yes, 5 by 8. Both numerator and denominator having plus sign, positive sign. So it is our required answer. Okay now. Now let us go to the third question. The third question is, 5 into minus 6, 5 into minus 6 into minus 9 by minus 3 into 9 into 4. Am I right? Yeah, minus 3 into 9 into 4. Now what is the simplest form of these numbers? That means if there any cancellation between them, we can cancel. First number 5, second number minus 6, third number minus 9. So all are having into symbols between them. Here also. Now let us try to simplify this. Here minus into minus become plus. Then there will be only 5 into 6 into 9. But here only one negative number. That negative as is minus 3 into 9 into 4. Now do the cancellation. Numerator 9, denominator 9 cancel. Because 9 table in 9. One time will come. Next, 3 table in 6 2 times cancel. 3 table in 6 2 times cancel. Now here this 2 and 4 cancel in 2 table. 2 ones are 2 twos are. So let me write 5 into 1 5 by 3 into 2. That means here minus into 2 minus 2. 5 by minus 2. But there is no cancellation between 5 and 2. Both are prime numbers. There is no common factor. So, but while you are writing in standard form, denominator should not have the negative sign. So, we need to write this negative sign to numerator. Minus 5 by 2. Minus 5 by 2 is our required answer. Okay, now. Check. So, let us go to the question number 4. The rational number 2 by 3 same as. 2 by 3 same as means we have some options here. 3 by 2. That means 2 by 3 same as means we need to take equivalent fraction of 2 by 3. So second option is 4 by 9. Third option is 4 by 6. And fourth option is 9 by 4. Okay. 3 by 2, there is no cancellation. 2 by 3 different, 3 by 2 is different. So first one is not our required answer. 4 by 9, 4 9 any cancellation? No cancellation. Because 4 table 9 won't come, 9 table 4 won't come. Both will not come in same table. This is also not a required answer. And 4 by 6, yes, both will come in 2 table, 2 twos are, 2 threes are. That means while you are writing 4 by 6 in standard form, it will give 2 by 3. So our required answer is 3. Because 4 by 6 is equivalent rational number of 2 by 3. Okay now? Right. Next question number 5. The fifth question is, in a rational number p by q where p comma q are called. Yes, p and q. Definition I said that p and q are integers. P and q are integers and q not equal to 0. This is our required option. Condition, that one. Problem number 6. That is minus 4 by 9 is dash. Option is rational number. Next, integer, fraction and natural number. Natural, it is not a natural number. It is a fraction, not fraction, because fraction having both the numerator and denominator positive. So minus 4 by 9 is a rational number. So this is belongs to rational. Okay, no? Yeah. So that's it for today, children. We'll continue the remaining problems in the next period. Thank you one and all. Have a nice day. Bye bye.